Okay, one quick video on horizontal asymptotes, which again are just boundary lines for where the picture is going to approach the edges, right? When things get really far to the left and really far to the right, we know that our rational functions like approach that line. We just don't know if they're coming from above or below. But again, all these are just approach lines for the very edges of the graph. So we want to know like what they approach. And the shortcut that we learned is we can just look at the degrees, and the degree is just a fancy phrase for the highest exponent that you see, and you compare the top to the bottom. So the highest exponent I see on top is a 1. The highest exponent downstairs is a 2. When your degree is bigger, when your exponent is bigger downstairs, this denominator carries a lot of weight. It drags the whole thing down to 0. So your equation, by the way, for horizontal asymptote is always y equals, and the number is always based on comparing the degrees. So when the degree downstairs wins, the answer is always 0. So in this case, since 2 is bigger than 1, it's automatically 0. All right, so there's the answer there. But let's just, what would it be if there were some other cases? So let me take the exact same equation. I'm going to change it a little bit. What if it were 10x plus 2 over 5x minus 7? So instead of that old one, let's focus on this one. So again, someone's asking me for the horizontal asymptote, and the first thing I'm going to look at is I'm going to compare the exponents. The exponent here is 1. The exponent here is also a 1. So when your degrees match, when the exponents match, everything is basically balanced out, so you focus your attention on the front. So essentially we just have 10 divided by 5, and 10 over 5 is 2. So that would be your equation here. Okay, so I'll make up another one. Y equals 3x squared plus 7 over 6x squared minus 15x. Again, nothing crazy. I mean, it's getting a little more complicated looking, but remember, you're just focusing on the exponents. If the exponents match like they do here, and again, you don't have to look at any other ones. We're just comparing the highest one. So this doesn't have an exponent. This is a 2. This is a 1. So I'm just going to focus on these two. When they are the same, everything is balanced, and you just look in front. So the equation here would be 3x. I can change it slightly. If this equation was a 3x or 6x to the 4th, if the exponents are not the same and the bottom one is bigger, then the bottom always wins, and your exponent, your horizontal asymptote would always be 0. When it's bigger on bottom, it's always 0. When it's equal, you look out in front. Okay, hope that helps.